Okay. And then I think when I'm doing things side by side, I'll just like do a split screen with Chrome. I'll be doing
Over
that
the
part.
sides. Okay.
Yeah. But whenever you're ready.
Okay.
This, by the way, are you supposed to have
I don't have a class. We'll have a class next week.
Oh,
Yeah.
yeah, we can still like say just come next week.
Yeah. And we'll have food sometime later. I started too.
Okay.
Wait, do you want to record like of this too?
Oh, I guess you can turn off.
Okay, the event is not created, so I think they have, the event is not created, so I think the code will not work at 6 precisely, but I think I'm talking to Lila right now. I'm pretty sure she'll just like create the event and worst case scenario, we'll just present the code at the
Okay.
end.
Okay, sounds good.
Hi, everyone. For those who are just trickling in, we're going to be using Xcode later on during this workshop. So if you can get that installed right now, because it normally takes about 30 minutes, that'd be great. Should already be installed, but just in case if it's not on your Mac. And if you have Windows, you can just follow along for now.
Yeah,
Or you can borrow Keon's MacBook. Yeah.
and mine too.
And mine too.
I really know that.
Okay, should we start? Okay, maybe we'll start in like 2 more minutes. Do you think the whole thing will be like an hour time?
Yeah,
Or-
if we end shorter, we'll do the MongoDB. Yeah.
Start.
Yeah, we can
start.
Okay.
Okay, hi everyone. Wait, did we start recording?
Yeah, we did.
Oh, we started. Okay. Hi everyone. Thank you for coming to today's session. Our first session of Stackschool, Intro to Full Stack Mobile Dev. My name is Sneha.
My name is Sam.
And throughout our workshop series this quarter, we're going to be working on building, if you saw the description, a mobile app using Swift and MongoDB for our database. And we'll go more into like what those things are and get you guys all started up for today during our workshop. Okay. So if you want to follow along, here are the links. That's a QR code for the link to our slides and a link to the Discord where after our session today, the recording of this session and the code we went over and the slides will all be posted there as well. Okay. And here's another link to the slides and a link to the README for the demo project we're going to be building this quarter. Okay, and if you're following along with the ACM membership portal, the code is currently not working, but we should have it working by the end of the workshop. So we'll show this screen again with a code if you guys want to sign up for the membership points. Okay. Okay, so a brief overview of what we're going to be covering during our workshop series this quarter. So this is week 4. We had kind of a late start to our workshop series just because the break last week on Monday and obviously the situation at UCLA, and we wanted to make sure that we were prioritizing everyone's safety. So we have a condensed workshop series this quarter. We're going to have 5 sessions. And today we're going over the intro to full stack mobile dev. Okay, so our agenda for today is going over what is mobile development, talking a little bit about what full stack is, giving a brief intro to Swift, which is the programming language we're going to be using, and then giving a quick demo for setting up the project. Okay. And in case you weren't here in the beginning, we have a few installations. If you're in or have taken CS 31 or 32, you probably already have Xcode. But otherwise, just in case, you can start downloading it now just because it takes a little bit of time. And then if you downloaded it now, you'll be ready to use it near the end of the workshop when we're doing our demo. And if you have a Windows, unfortunately, developing on iOS apps is restricted to macOS, but there are a few workarounds, and also we have a few.
Turn it on.
And we might have a few people some of our officers who have a Mac laptop who later on when we're doing the demo, you can use their laptop to start setting up the project, or also just follow along the content to learn. Do you want to demo that?
All right, so really quick, I'm just going to show you what app we're going to build by the end of this workshop series. So without further ado, this is an app called Bruin Eats, where a user can post reviews to the different dining halls on UCLA's campus. So we'll just demonstrate how it works. So you can create an account. Oops. Yeah, I spelled it wrong. Don't worry, I'll use a different account. Guys, this definitely works. All right, great. So now we have a list of all the different restaurants on campus, and you can add different restaurants if you want, and post reviews to the dining halls that you like or dislike, etc. And you can see it's a full-on, full-stack mobile app that it covers all the requirements that you need for example, CS35L, because it has a server integration that stores all the user's information. And if that sounds very high level, don't get scared. It just means that this app can communicate between different users. And so it's really cool. And by the end of this workshop series, you'll all get a taste, haha, of how to build this. Okay, back to you.
Okay. Sounds good. And so if you want to follow us along in building this app, you can, but also all the skills we'll be teaching are transferable. So if you maybe want to make an app related to like a different topic, you can use all the things that we're talking about to make an app about whatever you like as well. Okay, sounds good. So first, let's go over a brief intro of just giving some motivation for what mobile development in full stack is. So mobile development is creating software applications that run on mobile devices like phones, tablets, and smartwatches. And they run on different platforms, including iOS, which are Apple devices, and also Android, which are Google-powered devices. And there are 3 different types of mobile development: native, mobile web apps, and cross-platform and hybrid apps. And we'll talk a little bit more about what each of these mean and which type we're going to be developing in our workshop series. So native apps are apps that are created for one specific platform or operating system, and they're installed directly on our mobile devices and developed with platform-specific tools. So if you're developing an iOS app, you can make it with Objective-C or Swift, and if you're making an Android app, you can make it with Java.
Don't do Objectives.
Okay, yeah. Yeah, because we're teaching Swift this workshop. Okay. And then the other 2 types are mobile web apps, which are responsive versions of websites that work on any mobile device. And they're delivered using a mobile browser like HTML, CSS, or JavaScript. So when you open up Safari and you're looking at like Instagram on there, or Twitter, or a different kind of site, they have a different view than you would for like a website on your laptop. Okay, and there are also cross-platform apps, which are apps built with a single code base that can run on multiple different platforms. And these can be developed with languages like Flutter and React Native. And just real quick, can anyone tell me, like, now that we know the different types of apps that there are, which one of the 3 types are we developing in our workshop series this quarter?
Whoever answers first gets a prize next session.
We have prizes that haven't come in yet, but they'll come in next week.
So make sure to come back.
Yeah. Does anyone know? Yes.
Native.
Native, yeah. So we're making a native app because it's created for one specific platform using Swift. And in our case, we're developing it for iOS apps. Okay, so now we're going to go over what full stack is. So full stack is a type of development where you're working on all parts of the application that you're building, both the front end and the back end. So the front end of an app is the part of the app that the user can see and interact with directly. It includes the buttons that you click, colors you see, and pictures on the screen. So basically everything that you can interact with and see when you open up the app on your device. And then the back end is the behind the scenes part of an app, which manages data, performs computations, and interacts with the database. So users and us, basically, when we open up an app, we don't directly see this part or interact with it, but the back end is basically what allows us to, when we close an app and open it again, have all of our data show up again and interact with other users who might be using the same app as us. Okay, and this is just a quick picture of some of the breakdown of things we're going to be covering later on. Don't worry if some of these terms seem a little foreign right now. We'll be going over all of these later today and in our subsequent workshop series. Okay, and this is just a quick example of TikTok. All of the things like the For You page or search things that you see are part of the front end. And on the back end are all of your algorithms and things behind the scenes. Like when you search up something in your search bar, the back end is kind of what's deciding what's going to be shown on your screen. Or when you're swiping and liking things, algorithms in your backend are going to be deciding what kind of things that you like and seeing and analyzing all of your data to decide what to show you. So, yeah. Okay, now breaking down the components of what we need to have for our app. First, we need to have a beautiful user interface that our users can interact with. This can include a home screen to show our feed, a user profile screen, and a way for the user to navigate between the different screens. We need somewhere to store our data, which is our database, and store information like our user info, like username, posts we've made. And also, if we're making any posts, we want to store that information. In our case, we want to store information like our cafe and restaurant name, the owner of our post, ratings, and comments. Okay, but is this all that we need? No, it is not. We need one more thing. We want a middleman that is going to go between our database and find the data that we want and then carry them back to the front end for display.
Quick question. Can anyone name what that middle person would be? What is the term for that? You? Yeah, I was looking for a different one, but that
Does
works.
anyone else
Yeah.
have a different
Anyone
answer?
else? Think about like a restaurant. Like what is at a restaurant?
A server.
Yes.
Great.
Yeah.
What's your name?
Yeah.
Kevin? Okay. I'll write you down for next time.
Okay. Okay, yeah, exactly. So that's what servers do. On the front end, when you click a button, the request goes to the server, and the server processes the request, gets the necessary information, and sends the response back to the front end. Like Sam mentioned, kind of at a restaurant, on the front end, like we're placing our order, our server takes our order, they go to the back of the restaurant, which is our back end, get all the stuff necessary and required, and then come back to us at the front end. Okay. Okay, so now we've gone over some of the things we need, a user interface, a database, and a server. And can anyone tell me kind of what components each of these falls under within the front end and the back end? Someone who hasn't answered before. Yes,
User interface, the front end and for the back end.
yes. And what's your name?
Thank you.
Exact. Yeah, sounds good. That's exactly correct. Okay, and now that we know a little bit about what mobile development is in general, we're going to be going over some more specifics on an intro to Swift.
All right. Excuse me. So when you're doing mobile development, right, you have so many options. It can be so overwhelming. So which like style of mobile development are you going to choose? Well, um, the answer is obviously Swift, but let's just get a brief history on Swift, and then I'll explain why it's such a great language to use to develop mobile apps. All right, so back in the 1980s, Apple used Objective-C, which is kind of an extinct language now, to program iOS apps. And the great thing about Objective-C is that actually there's not very much great about it. But in 2014, it got replaced by a new programming language called Swift that Apple developed in-house. And it had multiple advantages over Objective-C. So Objective-C had a lot of issues that came with it being backwards compatible with C. And C is very like not fun if you've taken CS31 or CS32. So Swift, which is much more similar to a higher level programming language like Java, is going to be much easier to develop in. So yeah, we don't like Objective-C, and you should develop in Swift. So Swift is a native programming language. There are obviously two different types of apps, Android and Apple, or iOS apps. Android primarily uses Kotlin or sometimes Java, whereas Apple uses Swift. And why should you learn Swift? Well, it's not written here, but just so you know, Swift actually pays more than Kotlin. So get pwned, Android. But also iOS is a really big market in the US, and it's 3 times faster than Objective-C, and it's also open source. And I also have a joke right now. Why did the Mac cross the road? Well, you're supposed to answer. To get to the Apple Store. So this is why you should program in Swift, so you can publish your apps on the App Store. And hopefully at the end of our workshop series, we can maybe give you some tips on how to do that if we get there. Great. So yeah, this is actually not true. Swift does have closures. But anyways, so by the way, a show of hands, how many of you already know how to program in Swift? Oh, one person, 2 people. I'm assuming there's a few more, but I mean, it's okay. This is a beginner-friendly workshop, so we'll give you the details that you need to know and get started. But we'll also link some other things later on that you can practice on your own with. Okay, so I was talking a lot about Macs and what goes well with a Mac. Anybody? Okay, cheese, like mac and cheese. But in the same way, Swift UI is part of Swift. So Swift UI is actually probably the main thing that makes Swift good. And essentially, it is a framework or library within Swift that contains all the different functions that we need to build very beautiful looking UIs. All right, so this is what we'll be building pretty soon in Xcode. Yay. Okay, so let's just give a brief crash course on Swift. And it's okay if you don't fully understand the syntax for this session because we're not actually going to be doing that much like programming logic. We're going to be mainly doing UI. But just so you know, the most important function, the print function, is very simple. It's just a print statement. Any questions? All right. Also, there's no semicolons, so that's even better. And also, do not use semicolons when you have a single statement in a line. My general advice is just don't use semicolons at all. You don't need to put them multiple statements on a line, but there's no need to use semicolons in Swift, which is great. Okay, and then this is the potentially confusing part. So you may or may not be familiar with like let and var syntax from other languages, but in Swift, we use let and var keywords. So let creates a constant, var creates a variable. Does everyone understand the difference between a constant and a variable? Raise your hand if you don't. Okay, that's good. Well, a variable is essentially something that you can change the value of, whereas a constant, once you define it, you cannot change its value. And if you do, there will be an exception. Okay, so when we declare a variable, you can list the type of the variable. And the types are all uppercase. So that might come as a surprise, but that's how Swift works. So we have int, string, bool, double, and a few other types that I'm not going to get into in this session. But to declare a variable, you just write var and then the variable name and then colon the type, and then you just place in the value. And by the way, the type is optional, so you don't actually have to put it there if you don't want to. The compiler will figure it out, but it's a good practice to do so. So here are just some examples. All right. And then the operators in Swift are the same operators as in C++. So that's really convenient for us. We just have the arithmetic operators that I'm sure you all know, and then the conditional operators as well. So hopefully you don't get confused. And then one cool thing about Swift is that we have string interpolation. So instead of doing string concatenation like we have in this example where you do a plus, which is fine, you can also do string interpolation by doing a backslash parentheses and then the variable name into your string. And this, you don't need to know this to code in Swift, but it'll definitely make your life easier. So I'm just putting it out there. It's a very good show. All right, poll time. So I'm gonna give you guys just maybe 30 seconds to think about the answers to these two questions, and then I'm gonna call on somebody, and if you get it right, I'll put you down for a prize next time. So yeah, think about what these different statements will print. Any guesses? Yes? Anybody there? No. Correct. That's right. Okay, and then what about the second one? That's okay. I can go on to someone else. Does anyone know the answer to the second one? Oh wait, and sorry, what was your name? June? Great. Thank you. What about the second question? Come on, guys. This is as simple as like Python. Okay, anyone who answers, I'll give you double. Okay, 3, 2, 1. I'll just say it. It says, "Welcome to my app." Um, actually, no, it says 5. I'm sorry. You can see that typecasting is automatic in Swift, so that's really great. All right. So speaking of conditionals, we have if and else statements inside of Swift. So it's very similar to how you make if else statements in, for example, C++, but you don't actually need the parentheses around the conditionals. But you can add them if you want. You just don't need them. There's no else if though, by the way. Or there's no elif. You can make an else if. Yeah, just like that. Cool. And then functions. So pay attention because this one can sometimes trip people up. So our keyword to define a function is func. Then you make the name, then you specify the arguments. And when you specify the arguments, you put the type after the name of the parameter. And parameter is just another name for argument. And argument is just another name for a variable that gets passed into a function, in case if people don't understand. Yes.
Just to quickly cut in, so if you're finding reading the code blocks a bit boring, as I am right now,
Okay.
I posted a website in the resources channel of Stackschool. Basically, it's a website that you could use to run some very basic Swift code without doing any installation like Xcode. You can also probably run it on a non-Mac laptop, I'm assuming. But yeah, if you want the URL, it's onlinegdb.com. So you could you could use that for different languages. I use that for C++ and for JavaScript sometimes, but remember to select the Swift language for this workshop for this purpose.
Great. Okay. Thanks, Shio, for letting me know. Okay, I guess this is all like pretty boilerplate stuff for you guys then. So I'll just go through it really quick. No. Oh, okay. Never mind. Okay, so just bear with me, guys. This is only gonna take a few more minutes at most. Hopefully. Okay, so return type. You put after the argument, use an arrow to specify the return type. Similarly to how you would in Python if you wrote it out. Okay, so hopefully that makes sense. Does this not make sense to anyone? Great. Okay, so then you can call the function like this. You don't, oops. So you can specify actually the parameter name when you pass in the value to the function. All right, so let's do a review. Question 1, what gets printed? Okay, let's go fast. Yes, you're right. Okay, great. And then question 2, does anyone know what gets printed here? Did you say 12? What? 3?
Oh wait, no, 12, sorry.
12? What? That's right. What's your name? Oh, Lavender. No, I'm just asking that rhetorically. Um, okay, great job. Now, oops, that's weird. Now, let's briefly talk about arrays. So arrays are one type of way to aggregate data in Swift. There are also lists and structs, which we won't talk about today, but you can look it up and we'll talk about those later. But arrays are probably the most simple because they can only store one data type throughout the entire array. And you can use either let or var when you create your array to make it mutable or not mutable. Does that make sense? Cool. And it's zero indexed, just like most programming languages. And you can iterate over an array using a for in loop or the for each function. Personally, I prefer for in because it's easier to grasp if you come from other programming languages. But just so you know, there's also a for each function that allows you to iterate through arrays. Cool. So there's a lot more syntax related to Swift that I could talk about forever, but I'm not going to today because we have to move very swiftly. But you can check out the Swift Playground and download it on your Mac, which is a app on the App Store where you can just play around with Swift pre-designed playgrounds that Apple has already built for you to learn the syntax. And it's really fun. So try it out. Okay, now let's go to the actually important part, or I could say the cheese of Swift, which is Swift UI. And Swift UI is a one-of-a-kind thing. I can't describe it without showing it to you. So all I can say is that it's way better than UIKit, which was what was previously used. And you don't need to know about what that was because Swift UI is now here. Okay, so Swift UI, it is a framework within Swift that defines how you can build and design the UI of your apps. So now let's open our laptops. Does everyone have Xcode installed?
Does anyone need help installing Xcode, or does anyone want to put them out? If I haven't asked them.
Okay, let me know if you don't have Xcode installed. You don't have a Mac. Okay, just you can follow along for this session and then ask the library to borrow Mac for next session. Oh, you can have Tion's Mac actually. But let's go ahead and open Swift. So, I mean Xcode. Okay, I already have mine open, but okay, so when you open Xcode, it should say like create a new project. And then when you click that plus button, you'll get to this screen. So is everyone able to get here? Yeah, cool. So if you look at the top here, we have multiple options for a new project. You can make it multi-platform, iOS, Mac OS, etc. Please select iOS, then click app, just like Apple, and then click next. And you can give your app a name. If this field is not blank, or if it is blank, just sign in with your Apple ID. This can be anything you want. We will be using Swift UI, Swift, and all the defaults essentially are good, and you don't need any storage for now. And you don't need a Git repo for this. Yeah, but just go ahead and create your app. And wait for it to load. And as you wait, click the upmost folder and go into build settings and scroll down. And where it says Swift 5, change that to Swift 6 if you want to have access to the latest version of Swift. By default, Xcode will put it as Swift 5, but Swift 6 is the most up-to-date version, so you can switch it to Swift 6. Ultimately, it shouldn't matter too much, but I just recommend doing that. And then when you go to content view, you'll be able to see the boilerplate code of the front end. Oh, yeah. Oh,
Is there a way to change the light?
oh yeah. There should be. Yeah. Okay, has everyone been able to get here and follow along to this point? Raise your hand if you have any questions. Yeah. Um, yeah, so you mean this folder, right? Um, This is actually an Xcode project file, but I just said go into the build settings when you click on this and then change the Swift compiler to Swift 6, just so you can be using the most up-to-date version of Swift. Yeah, does that make sense? Cool. Cool. So as you can see, I have an iPhone 16 Pro. I mean, it should be iPhone 16 something for most of your guys' Xcodes. If you're getting a Mac, please talk to one of the officers to help with you. But you can see we have a preview here, which is great. Oh, click the run button. Yeah, you can't. Someone will help you. Um, okay. But yeah, so we'll explain this more. Okay, just take your time, guys. While people are playing around, you can see in this preview, it just has a globe icon and then some text. And you can see we have an image view. And what is a view? I'll talk about that later. And a text view, which defines those two things. The actual main function is over here where we have this main tag, and this is what gets run. But the reason why I'm here is because we have a live preview tag that should normally produce a live preview here. I don't know why it's not, but it's over here. So yeah, cool. You can do a lot of other interesting things like reorient your screen, go to home. Great. So play around with that, but now we're going to get back to our presentation and learn a little bit more. Okay, so hopefully your Xcode looks similar to this. Just as a recap, here's the run simulator. This is your file hierarchy. This is where you'll code. This is the live preview. The code inspector is on the right-hand side. Cool, but now let's actually build something. So I'm not gonna lie, I kind of stole this idea from Nara, but hopefully none of you guys know who that is. And I'm just gonna say that I really love French toast as well. And we're gonna be building a UI that looks like this. So when you're building an app, what do you think about on like when you first think about building an app? Anybody?
What it will look like.
Yeah, exactly. So normally you want to have an idea of what your app looks like, right? So this is what we're going to go off of, but you can build it. I'm going to give you the tools to build any type of app that you want. So, and those tools are all categorized under this cool, I guess you could call it object or type inside of SwiftUI called a view. So we already saw in the boilerplate code the text view, and you just declare it by writing text and then inserting text. Then we also saw there is an image view for the globe icon, or in this case, it'll be French toast. And you just insert the file name. And then we can also add buttons. Buttons are a little bit more complicated because you can give them an action, but for now, we'll just put a name onto them. All right, so I'm actually going to go back to the Xcode we had open and just give a demonstration. But before that, actually, how about you guys take maybe 30 seconds to, where is it? Go to this website or Google Images, whatever you want, and just download some images you want to your desktop. All right. Pixabay is a place where you can download royalty-free images in case if you're very nitpicky about copyright. But if you're not, download any images you want. And I'm going to load the images that I downloaded into my boilerplate Xcode front end by going into the assets folder and getting my images up. Hmm. Okay, so once you've found some good images, and you can still keep looking for now, but just drag and drop it into your assets folder. You might have to first select app icon, by the way. But just drag and drop it in here. And it's loading really slowly for me. Okay, I just pasted it in. Either way, cool. But now we have some images that we can use in our project. So assets is where you place all the images that you want to use in your project. Unless if you have a URL, in which case you can dynamically load that image. Okay, that sounds like a lot of terms, but don't worry about that. Just paste your images into the assets container.
Does anyone need help? Or is everyone able to get the images that they want in the assets folder?
Okay, great. So okay, I'm gonna reformat some of this. We'll just go back into the plain view. So let's say I want to add some text that says, I like French toast. And then I want to add an image of my French toast, which is called French toast in my assets container. So I'll just type that in. And let's see how that turns out. Ooh, I think it's a little bit laggy because we're on Zoom.
Yeah.
Okay, give it a second, guys. What? Oh, okay. Okay, I'm gonna pause this for a second because it's lagging a bit on me. But has everyone kind of been able to paste images and text into their own Xcode and it works, right? Yeah. Okay, good. That's great. Now I'm gonna talk a little bit about, because if you pasted your image directly into the Xcode file, you probably notice it's not formatted in the size or the area that you want it to be. So how do we actually decide how to format things? For example, I have this beautiful app on the right that is so complicated. And can you imagine just putting like an image and a text and this turning up? Probably not. So we have to decide how to lay out our views. And the way that we do that is using stacks. So there are three types of stacks. A V stack, which is a vertical stack, H stack, horizontal, and a Z stack, which comes from the bottom of the app to the front of the screen. So whenever you design an app, it's a good practice to first, on a piece of paper, just label all the different stacks that you will need. And should be happy because this is much easier term of stack than the term stack inside of Stackschool or full stack development, by the way. But it's the same idea. We're just placing like plates on top of each other. And in this case, we're placing images on top of each other. So in a VStack, we have the views that you put inside of the VStack, and they'll display from the top to the bottom. So let's make a VStack. Okay, normally this would work, but I'm having some technical difficulties here. Oh, wait, maybe it works. Great, so yeah, the first line gets on the top, the second one gets under it, and you can keep adding more things, images, whatever. It'll all be great. Next, we have H stacks. So I'm gonna put an H stack inside of here. And I'll say okay, bear with me, guys. I think because of Zoom, my computer is a little bit slower than normal. But what do you think will show up on my screen? If you said really love toast, you're correct. So not see, we can put stacks inside of stacks. And normally we actually want to have a Z stack on the outside of our entire view because we want like a background, right? So we can just put a color here. I don't know. But yeah, that would be kind of the logic of using a Z stack. And this will take a bit to load. But test it out and see if it works. So do stacks make sense to everyone? Cool. Well, one thing you might have noticed is what if okay, see, great. Now I put a blue background. But this still looks kind of bad, right? I mean, it's not the exact formatting that I would prefer personally. So what if I want to put like some space between these two texts? Well, how can I do that? Well, guess what? Are any of you spacing out right now? Because you're on the right track because we have spacers in Swift UI and they can put space between different things in a stack. So you can put a spacer here. Maybe you can put one here. I wouldn't suggest putting them in a V stack. I mean, a Z stack though, because you won't be able to tell. But in an H stack or a V stack, spacers are great. So yeah, just try that out. And again, these are like the most basic views. There's obviously other ways to like add space, which I'll get into in a moment.
Here's that size.
You can change it. Yeah, did you notice it was too big or something?
No, but I can't even do with my iOS 18 now. I just, that
Oh.
looks like a question.
Yeah, well, you're right. You can change it. And how do you change it? Good question. If that was a question, which is use modifiers. So every single view you can call modifiers, or I guess you could call them functions on the view. And you just do that by calling dot modifier with parentheses. And there are so many modifiers, I can't even get into how many modifiers there are. But definitely search them up. But one great thing about modifiers is that you can chain them. So if you have like text and you want to make it font size, like cursive, large, and bold, you can have like 3 modifiers for all those things. Just keep on adding them back to back to back on your views. So for example, we have bold, italic, foreground color, background color, or I guess just background, font, line spacing. These are all great modifiers. I'm gonna add some right now. I don't know, just one thing I forgot to mention, by the way, um, and I should have mentioned this at the beginning, but there's this really cool button here called the plus button, where you can add modifiers and views and see all the different modifiers that you can add. So, um, let's say I wanted to add an opacity modifier. Then I can look at this, see some examples of how it works, and modify, for example, my color. So test that out, see if that works for you guys. One thing I also want to say, if you noticed inside of my background, whoa, yeah, okay. Yeah, my spacer has a lot of space in between. Um, but one thing, if you notice the background doesn't fill the whole screen, that's okay. You can just add a ignore safe area modifier, ignores safe area to your color, and then it should work. But there's so many modifiers, so just take some time to try them out, see what you come up with. And I haven't added my image yet, so I'm just gonna go ahead and add it inside of my VStack. Oh, and I also wanted to add a button, so I'm gonna add a button as well. If my thing stops lagging. Ooh, is this working? Yeah, so as you guys are playing around, just like think about the different views that you can add and look through this list right here because there are so many views. You can add a slider, you can add a table, a toggle button, you can make grids in addition to stacks, et cetera, et cetera, et cetera. So I'm not gonna go through all of these today, but just know that it comes with examples that you can copy and paste and just place inside of your app and then see how it looks on the right-hand side. And oh, I had an issue. Ta-da. Okay. Yeah, okay, I'm gonna move on, but I hope that gave everyone a good introduction to how to build your front end or UI using Swift UI. Yeah, I'll text in. Cool. I know it doesn't look like this, but if you spend enough time, you can make it as nice as this. Um, great. All right. And just so you know, by the way, if you update your Mac OS to the latest version, you can add predictive complete, um, which is really handy. Anyways. Oh, okay, that was a lot. Is everyone feeling comfortable with views, Swift UI? Yeah? No? Oh, shoot, why aren't you feeling comfortable? No, I'm just kidding. I'm hopefully everyone got a good like introduction to Swift using Swift UI. And these slides will be posted so you can check out those things more at the end. But um, remember that we added a button and it didn't do anything? Or at least there was supposed to be a button. Well, how can we actually put in the code for the button to do something? And that kind of brings me to the backend logic, or in our case, we're going to be talking about a design pattern called MVC, or Model View Controller. And that sounds really, really complicated, but it's actually very, very simple. All it means is that we are going to structure our code into 3 folders. One is called models, one is called views, and one is called controllers. So let me explain. Now, we already kind of know what views are, right? Because we just dealt with Swift UI views. And any file that is displaying UI information should be put inside of the view folder. So if you go back to our like original workshop, ooh, this file should go into a folder called views. And normally when you build an app, you're gonna have multiple screens. So you're gonna have multiple Swift files in this folder. But now we also have models. So if you remember at the beginning of this workshop, we demoed Brew and Eats, which was a cool app for people to lambast or extol whichever restaurants they really enjoy. But how can we do that without actually defining what a restaurant is and having information like the name of the restaurant or the image related to the restaurant, etc. So in the models folder, we will actually define our data structures, I guess you could say, or our objects. And we're going to have one for every single type of object we have. And we'll get into this more during our next workshop. But just so you know, the model folder contains essentially the behind the scenes data designs for all the different like data structures that are going to be relevant for your application. Cool. And finally, we have the controllers folder. So controller is where you're going to put all your functions that, does anyone want to guess what controller is going to do based on this diagram? Okay, do you want to elaborate a little bit on what that means? Like, so I talked about models, which contains like, for example, our restaurants, and then views, which contains like how the app looks. But if, for example, I clicked the register my account button, where do you think that would go into? Which folder would that go into out of model, view, and controller?
Model?
Um, no, not really. But I mean, it's related to model, but there's something that needs to connect our view and controller folders. So our view and model folders. And okay, I kind of said it. It would go into which folder? The answer is on the screen.
10 words up there.
I'll give you a hint. It's like this word. Yeah, that's right. Well, I'll put you down again. But yeah, so our controller will just contain all the logic for like how our views change when the user touches it. And so it is the middle, like just like servers are a middleman between a front end and a database, or I could say, yeah, between a front end and a database. Controllers are going to be a middleman between your UI and your back behind the scenes logic. Cool. So I know that's a lot, especially given that none of you guys came in here, except for some people with prior knowledge on Swift. But hopefully it shouldn't be that much because it kind of follows the same breakdown as like front end, back end, and server. You can just think of front end being like the view, back end being the model, server kind of being the controllers. And the reason why we do this, because we don't actually need to do this. We can just put all the code in one file, but you'll find that when you're building an app, that gets really large. So yeah, okay, I'm gonna stop talking really quick and just ask if anyone has any questions before we move on to the next section. Does anyone need a break? We can take a short break here. No one needs one? Okay, let's zoom on. After all, this is a Swift session, right? So oh, that was a lot. I just explained to you the entire Swift programming language, minus a few parts. And now I want to explain to you this cool framework called Vapor, which is a framework to build servers. So go ahead and type brew install Vapor into your terminal to just get this started while I explain what Vapor is. I already have it installed, so I'm not going to do this again, but you just type brew install Vapor. You don't have brew installed on your Mac, ask an officer, but you really should have brew installed. So they'll help you with that though. Yeah. But Vapor, I can like talk endlessly about Vapor because it's so great. It's better than Node.js. It's like almost as good as Go, which you see in this small little diagram over here. Unfortunately, Go is still better. This thing says that Node.js is better, but actually I would say Vapor is better. It's better for anything besides JSON. Obviously, JavaScript is going to win with JSON. If you don't understand what I'm talking about, it's okay, just breathe. Remember, a server is like the thing that fetches the cooked dish in a restaurant, right? So Vapor is how we build the server inside of your full stack application that's going to fetch the data from your database. And why do we need a database? Well, does anyone know why you would need a database in an app? Anybody? What do you think? Okay, next session we'll talk more about databases, but just to like explain a bit why we need Vapor, you gotta understand like when we built this app at the beginning, like Ruin Eats, there's like data related to each user, right? So where does that get stored? In the database, obviously, or maybe not obviously, but it actually does get stored there. So Vapor is going to be how we access and send messages to our database. Cool. Has everyone installed Vapor by this point? Not? Raise your hand. Everyone has Vapor installed? Not yet. Are you still installing it or you need help? Oh yeah. Normally I just type command plus and then search up the terminal. That's like a really easy way to get it. Cool. But I'm just gonna get going because I think we don't have that much time um left. But okay, so if you had followed along thus far, you will already have actually created a project, probably called Workshop 1 or maybe something else, right? That is your front end. So now let's go ahead and create a back end. So I'm just going to type in Vapor new backend, or you can name it whatever you want, but I like to call it backend personally. And I already have one, but I'll just make a new one. And I suggest typing this in the same folder where you have your project folder that you just created during this session. All right, has everyone gotten this part? Yes, no, maybe, okay. So now you can just type open package.swift inside of your terminal. And oh yeah, first type cd backend or whatever your project is named, yeah. And then just type open package.swift. And now we have our beautiful backend that is produced by Vapor for us. And it'll take some time to install some packages. But there you go. You just created a front end and back end already. You basically have the entire skeleton of your full stack app. Yes.
Backend, that's if I want fluent or no fluent.
Say yes, you want Fluent. Yeah. Don't worry about Fluent right now, but you do want it. It's going to be very helpful. Cool.
If I choose leaf or no leaf.
You can just say yes to everything. Yeah. All right. Okay, so I'm just going to give you guys some time to finish setting up Vapor. Yes? Not quite. So let me show you how mine is structured. So you see, I created my workshop 1 folder here, and then inside of this like folder above that, I created the backend. Yeah. And hopefully you don't have these other things in your folder. It's just front end and back end. Ignore these parts for now. Yes. Good question. So after you create it, right, type cd backend or whatever you named it, and then type open package.swift, and it should open for you automatically. Oh, yeah. So we'll explain more of this in the future, but just as a cool preview, if you guys are familiar with servers and you know they have like routes, it already gives you some. So if you're not familiar, ignore what I said. But congratulations, everybody. We have finished our entire workshop minus a few parts that we decided to move and wait till next time to do. So there you go. You just created a front end, a back end, learn how to use Swift. And next time we'll be adding a database and hopefully you'll get a complete mobile full stack web app, mobile app running within the next few workshops. So congratulations, guys. That's all I have for you. If you have any questions, stick behind and come back next time so I can distribute the prizes and I'll let you know what they are next time. All right. Thank you.